When most people hear Artemis, they think of the moon, a return to the lunar surface, new astronauts, new landings, a modern version of Apollo. But what if that is only the surface of the story? What if Artemis is not really about the moon, but about Mars? Because the more you look at what NASA is testing, the clearer the bigger plan becomes. Artemis is not just about going back. It is about learning how to live beyond Earth, how to build shelters, how to use local resources, how to keep astronauts alive in a hostile world, far from home. And that matters because Mars is not just another destination. Mars is a survival problem. Its surface is freezing, dusty, exposed to radiation, and protected by almost no atmosphere or global magnetic field. The futuristic bases we imagine sitting openly on the red surface may not be realistic at all. The first real Martian bases may need to be underground, hidden beneath rock, buried under the soil, protected from the planet itself. And that changes the way we should look at Artemis, because the moon may only be the test site. Mars may be the real plan. Artemis is often described as NASA's return to the moon, and technically that is true. But this time, the goal is not just to land, collect samples, take pictures, and come home. Apollo already proved that humans could reach the moon. Artemis is trying to prove something much harder. Can humans stay there? Can they operate for longer? Can they build systems that survive in deep space? Can they prepare for missions where Earth is no longer just a few days away? That is the real difference. Artemis is not just a repeat of the past. It is a test program for the future. Every rocket launch, every Orion flight, every spacesuit, every lander, every planned habitat is part of a much bigger question. How do you keep humans alive beyond Earth for weeks, months, and eventually years? Because before NASA can send astronauts to Mars, it needs a place to practice. And the moon is close enough to reach, but hostile enough to teach us what survival really means. The moon is the perfect training ground for Mars. It is close enough that astronauts can reach it in just a few days. But once they are there, it becomes an extreme survival environment. No breathable air, no liquid water on the surface, no thick atmosphere, brutal temperature swings, radiation from deep space, and dust that can damage equipment, suits, and machines. That is exactly why the moon matters. Because every problem NASA faces there becomes a lesson for Mars. How do you generate power when the environment is hostile? How do you build habitats that can protect a crew? How do astronauts repair equipment when there is no quick rescue? How do you use local materials instead of bringing everything from Earth? This is what Artemis is really testing. Not just how to visit another world, but how to start living on one. Mars is not just a farther moon. It is a completely different kind of mission. A trip to the moon takes days. A trip to Mars takes months. And once astronauts arrive, they cannot simply turn around and come home whenever they want. The distance, the timing of the planets, and the limits of spacecraft technology mean that a Mars mission could last years. That changes everything. Every system has to be more reliable. Every repair becomes more critical. Every mistake becomes more dangerous. On the moon, Earth is still close in the sky. On Mars, Earth becomes a tiny point of light. That is why Artemis matters so much. Before NASA can send humans that far, it has to prove that astronauts can survive, work, and adapt in places where Earth can no longer save them quickly. Mars is not just about exploration. Mars is about independence. When we imagine a future base on Mars, we often picture something sitting proudly on the surface, a bright habitat, a glass dome, astronauts walking outside under a red sky. But the surface of Mars is not friendly. It is exposed. The atmosphere is extremely thin. The temperatures can drop brutally low. The dust can cover machines, block sunlight, and wear down equipment. And without a global magnetic field, radiation becomes one of the biggest threats to human life. That is the problem. A base on the surface might look futuristic, but it may also be vulnerable. On Mars, survival may depend less on building upward and more on digging downward, because the safest place for humans may not be under the sky, it may be under the ground. Underground bases may sound like science fiction, but on Mars, they could be one of the most realistic ways to keep humans alive. The idea is simple. Use the planet itself as protection. Instead of placing habitats fully exposed on the surface, future crews could bury them under Martian soil, build them into natural caverns, or place them inside ancient lava tubes. That layer of rock and dust could help shield astronauts from radiation. It could reduce the danger from temperature extremes. It could protect equipment from dust storms, and it could make a base much easier to defend against the harsh surface environment. This is why the future of Mars may not look like giant glass cities under the red sky. It may look darker, deeper, more hidden. Because on Mars, the question is not just where humans will land, it is where they will survive. One of the most interesting possibilities for future Mars bases is the lava tube. On Earth, lava tubes form when flowing lava creates underground tunnels, and scientists believe similar structures may exist on Mars. But on Mars, they could be much larger. That matters because a lava tube is not just an empty cave, it could be a natural shield. The rock above it could help block radiation. The underground space could stay more stable than the surface, and astronauts could use it as a protected area for habitats, storage, laboratories, or even future construction. Instead of building every wall from scratch, humans could use a structure the planet already created. That is why lava tubes are so exciting. They could turn Mars from an exposed, deadly landscape into a world with hidden shelters beneath the surface. Before humans can live underground on Mars, NASA has to prove the basics much closer to home. That is where Artemis comes in. On the Moon, astronauts can test the systems that a future Mars crew would depend on every single day. Pressurized habitats, reliable spacesuits, life support, power systems, water recycling, air recycling, long surface missions, emergency repairs far from Earth. Because a Mars base cannot be fragile. If something breaks, astronauts cannot wait for a rescue team. They may not get a replacement part for months or even years. So Artemis is not just testing rockets, it is testing survival. Every lunar mission becomes a rehearsal for a place much farther away, where the stakes are higher and the margin for error is almost gone. Before Mars can become a home, the Moon has to become the classroom. A Mars base cannot depend on Earth forever. The distance is too great, the travel time is too long, and every kilogram launched from Earth costs time, money, and fuel. So future astronauts will need to use what they find around them. This is called living off the land. On the Moon, Artemis can test that idea with local resources. How to search for ice, how to extract useful materials, how to turn hostile soil into construction material, how to produce oxygen, water, or even fuel with what is already there. And on Mars, this becomes even more important. A buried base or underground habitat would need power, air, water, spare parts, and protection. It cannot survive only on supplies from Earth. So Artemis is not just about reaching another world. It is about learning how to use that world to stay alive. But surviving on Mars is not only an engineering problem, it is also a human problem. A future Mars crew may spend months traveling through deep space, then months or years living inside a sealed habitat, far away from Earth. And if that habitat is underground, the protection comes with a cost. No open sky, limited space, artificial light, constant routines, and the psychological pressure of knowing that home is millions of miles away. That is why Artemis matters here too. The Moon can help NASA understand how astronauts handle isolation, confinement, stress, and long missions in a hostile environment. Because a Mars base can not only keep people alive physically, it has to keep them stable, focused, and mentally strong. On Mars, survival will depend on machines, but it will also depend on the people inside them. The first lunar outposts may not look like future Mars cities, but they could become the blueprint for them. On the Moon, NASA can learn how to assemble habitats, manage power, protect crews from radiation, and use local materials for construction. Then, those lessons can evolve. A lunar shelter becomes the prototype for a Martian habitat. A radiation shield becomes a buried base. A test mission becomes a survival strategy. And this is where Artemis becomes bigger than the Moon, because every system tested there could eventually be adapted for Mars, not just to land humans on the red planet, but to build the first places where they could actually stay. And if that happens, the first true Martian settlement may not rise above the surface. It may begin underground. This is the bigger picture behind Artemis. It is not just a moon program. It is a survival program. Every mission, every test, every habitat concept, every new technology is helping answer one question. Can humans truly live beyond Earth? The Moon is close enough to practice. Mars is far enough to prove whether we are ready. And that is why underground bases matter so much. Because the future of Mars may not be bright domes under a red sky. It may be pressurized tunnels, buried habitats, lava tubes, shelters hidden beneath the surface, using the planet itself as protection. So when we watch Artemis return humans to the Moon, we may actually be watching the first steps of something much larger. Not the end of Apollo's story, but the beginning of humanity's path to Mars.